Hello everyone, welcome to Brain Educational Convert again. Here with me my own self, Kabir. So in this video, we are going to be looking at a question or maybe two. Maybe this session will be broken into two. This video and another video. So the topic we are going to be looking at is elasticity. Elasticity. Elasticity is a very interesting topic. It's just the ability of the material to retain its original form after force has been removed, provided the elastic limit isn't definite. For example, I have a rubber. If I apply a force and I leave it, you notice that if you give me that calculation, you notice that the rubber still retains its original shape when I remove the force. That is what elasticity. So if I see force, I mean rubber start to release, I will not release it. You know that you will injure. So if I say I want to apply more force, at a point it will come to its original form. If you cut, in that case, you are not looking at elasticity. So that's why this also comes with provided the elastic limit is not exceeded. If the elastic limit is not exceeded, that's when it will be able to come back to its original form. That is elasticity. And who gave this law? It is Hooke's law. It is Hooke's law. Take note. So how do I now come about this? You notice something. More force, more extension. If I apply small force, you see that the extension is small. The new length of the rubber is small. Another person that is more is big. Like that. If I reduce it, you see that the length is becoming smaller. Which simply means the extension gets smaller. If I reduce it, you notice that it's getting smaller. Like that. So that means more force, more extension. Less force, less extension. And it simply means directly proportional. But directly proportional simply means up, down, down. So that means force is directly proportional to extension. Therefore, F is equal to K. When you make K the subject, K will now be what? F all over A. That K is called the what? Elastic constant. Take note. And there are also some other things you need to know in elasticity, like strain, like stress, and Young modulus. Strain is extensions over original length, and while stress is force over area, and Young modulus is stress over strain. So now we're going to be looking at the question to for a question under this elasticity. What is that question? A piece of rubber 10 centimeter long stretches 6 millimeter while a load of 100 newton is hung from it. What is the strain? This question is sometimes some question for start to find it a live and direct. Look at this. Let's partialize the question. This is the rubber is 10 centimeter long. When I stretch it 6 millimeter, the force that I used to stretch it is 100 newton. You are not able to find the strain. So in that question, the original length is 10 centimeter. But it said a piece of rubber 10 centimeter long, which is something like this. The extension is 6 millimeter. When I extend it, let me tweak it. Let me use the original length. When I apply small force, it becomes this. So this one here is the extension. This is the original length, this is the extension. Then the new length will be the original length of the extension, which is this like this. So this is L1. So this L1 is L0 plus this. So that's what I'm trying to do here. And we know that strain is what extension of our length. What is the extension? 10 centimeter. No, what is the extension? 6 millimeter. What is the original length? 10 centimeter. And it's something you need to take note of. You need to take note of the unit. They must be in the same unit. So I convert this to meter. If I convert it to meter, it becomes 6 times 10 raised to power minus 3, which is 6 all over 1000. What I did here. Then 10 centimeter is what? 10 all over 100, which will make it to be meter. And with that strain is what extension over length. What is the extension? 6 all over 1000 divided by what? 10 all over 100. So it becomes 6 all over 1000 times 100 all over 10. And that is 0.06. Will it have unit? No. Why? Because the unit of this is a meter and the unit of this is a meter. So meter cancel out meter, so it does not have unit. If the usually have that thing detail. So that is that on the particular question. If you are, so let's look at the second question. Like I said, the first question is from 1973 question 45. The second question is 1981 question 43. And the question goes off. The extension in a string when 5 grams was hung from its mass, let's just say mass 1 equal to 5 grams, was hung on from it is 0.56 centimeter. So E1 is what? 0.56 centimeter. Now, if Hooke's law is obeyed, what is the extension caused by 20 grams? So mass 2, 20 grams. What is the extension? E, we don't know. But I said something here. I said this is a constant. It is called the elastic constant or the spring constant. And it is a constant, meaning it does not change. All these are variables. F and E here, they are called variables. So F and E can change, but K does not change. If you are looking at the same material, imagine looking at the same rubber. If I extend it or reduce it, or anyhow, the elastic constant of this rubber will still be the same. Because the elastic constant is just the ratio of the force and the extension. So just like saying more force, more extension. But the ratio, once you divide it, you see the elastic constant. So if you do not change the material, the elastic constant remains the same. So this 5 grams is just like it's still cost. Just change the gram to 5 newton and change the 20 grams to 20 newton. But though, how would I put it? The reason why I'm doing this is because at the point, if you cancel, don't worry, I'll explain it. Let's say we have K is equal to X over E, which is the elastic constant. Because here we're looking at two scenarios. You can say F1 all over E1 is equal to F2 all over E2. So if I want to make this E to the subject, it becomes F1 E2 is equal to F2 E1. Making E to the subject, E2 becomes F2 E1 all over F1. Take note, this F2, we use it as graph according to the question. This F1 too was used as graph, meaning I can still maintain. If I convert it to Newton, I have to convert it to Newton, and according to this division sign, they will cancel out. So let's just give a little tap. Convert it to Newton. You get. Yeah, I'll leave mine in graph. We'll see if we get the same thing. If we get the same thing, let me know in the comment section that we got the same thing. But it's nothing special. We'll get the same thing. So what is my F2? My F2 is what? 20 times. What is my E1? My E1. So the same thing also works for this E1. There's no need to convert it to meter. Whatever unit is here will be the unit of my E2. Okay. Whatever unit is there will be the unit of my E2. So therefore, my F2 is what? Let me just solve it. 20. My E1 is 0.56. So my F2 is 20, my E1 is 0.56. So because E2 is equal to 20 times my E1 is 0.6 centimeters all over. So yeah, I'm doing F2 times E1. Then my F1 is what? 5. So because 20 times 0.56 all over 5. 5 here 1, 5 here 4. So because 4 times 0.56, which is 2.24 centimeters. So take it, and unit 18 centimeters. So that is what I do tell them in the tutorial. Because some scholars they might want to be converted because you know that it must be in Newton, it must be in Newton. Fine, yes, it must be in Newton, but in a situation like this, when there is a divisor sign, maintain whatever unit is there. Look at this is graph, maintain graph here. The reason why you can maintain is because of this divisor sign. So learn all this tricks. They are not really difficult. All this will save your time. Even though you arrive at the same answer, but it saves your time. So if you have any question as usual, please feel free to let me know on the comment section. And I want to use this medium to let you know about our orientation program that we hold on WhatsApp on the 13th of September. Here, past students of mine like gifts. Yes, like gifts. One of the top 10 in UTME 2026 is going to discuss with you how you are able to achieve that result. So please and please do not miss it. If you are looking for the link is posted on my bio. You see it, the link to the WhatsApp group. Here the orientation is going to post is posted on my bio. Do well to check that link and share to your friends. I still remain my humble self, Mr. Ben. Bye for now. Yeah, that's all. That's all.